All right, what we're going to be doing today is moving forward with our quadratics and looking at trying to solve monic quadratics as opposed to non-monic quadratics. Now, we knew that last lesson when we looked at a monic quadratic and we're looking at our standard form here, this value here, a, for it to be monic, means it's going to be a 1. The, the a value is 1 when we're doing that. And what we're going to be moving on to is looking at something that's a little bit different. And when I say a little bit different, I'm going to be looking at this idea of factorising a non-monic quadratic. When we're factorising a non-monic quadratic, what we're looking at is when the a value is not 1. And that's any other quadratic except the very special case of a monic quadratic. More often than not, you're going to see a non-monic quadratic when you're dealing with modelling and things like that. When you're dealing with quadratics in the real world, as opposed to dealing with quadratics in the math world. So there's this example here of how to solve it, and when we looked at trying to solve a monic quadratic, there was this idea that you multiply to get the c value and then add to get b. So find two numbers that multiply to get me c but add to get me b. When you come down to this idea of factorising non-monics, there's a bit more work that's kind of involved in being able to do that. That's here. Now, if you need to, pause it, go and copy that down, probably a good idea. But I'll also go through that as a bit of an example as we go through. So what I'm going to do is I'm going to put an example up here. We'll go through it together, see how we go, and then we'll do some practice ones after. All right, here's my example. Y is equal to 3x squared plus 7x plus 2. And we're going to have a look at trying to do that. Now, I'm going to step out those steps that are above, so that gives you a bit of an idea of how you can use that. Hopefully you've got them written down. Very, very handy to have written down. All right, step 1. I have multiply A and C. And when I do that, what I'm going to get is 3 times 2. And that's going to equal 6. Now, we've got this idea of 6 here. Hopefully, you're starting to recognize we need to find some factors of that number. So you can do that down here. So factors of 6. So I'm going to have 1 and 6, 3 and 2. Now, you don't need to write this out every time. It's just me sort of showing you how to do it. I want to have a look at those factors, and out of those two sets of factors that I have, figure out which one I have that adds to give me my b term. Okay, so step number 2 is find factors that add to give me b. Okay, hopefully you can see that the factors I'm going to use are these ones here. I'm going to use those ones there because 1 and 6 add to give me 7, which is the b value in the middle just there. All right, so with that, okay, I've found my factors, which are 1 and 6. Step number 3. Step 3. Split. I'm going to split the b term. And you might be like, what the heck is he talking about here? And that's completely fair. When I split the b term, I'm going to get my y is equal to, leave my a term there, 3x squared. And then I'm going to use my factors that I have over here and replace the b term with these two factors. So you'll see, let's go over here, I'm going to replace them. So I'm going to go plus 6x plus 1x plus 2. Okay, so that is in line there with this thing just here. And I've split the b term, the 7x, I've split that into 6x and 1x. 6x plus 1x is going to be 7x in total. So I'll split that up. And the reason I've done that is so that I can factorize these things in parts. Now, if you haven't heard of that before, it means you can factorize long functions into different parts and we can start to work with them. It's a very handy thing to be able to do as you move into what we're looking at. So let's try and do that. Y is going to equal, I'm going to factorise out this part just here. I'm going to factorise the yellow part out and just the yellow part. Okay, so I want to know what's common between 3x squared and 6x. So what is common between those two is going to be 3x. That is common. What did I multiply 3x by to get to 3x squared? Just going to be x. What did I multiply 3x by to get to 6x? Well, that's going to be 2, so plus 2. Okay, now I'm going to factorise this thing here. It might be hard to tell from kind of sight what's common between those two things. The only thing common is 1. Okay, so we're just going to put a 1 at the front, plus 1, open my brackets, and then it's just going to be x plus 2. Okay, and the reason it is because you've just got a 1 at the front, and sometimes it's not going to be super easy to be able to figure out what it is, but 1 could be your go-to. What we're trying to do here is we're trying to get this thing here inside the brackets the same on both parts of the factorisation. So we factorise by parts, and I want to get this part here, x plus 2 and the x plus 2 the same. And the reason you do that is because hopefully it might take a little bit of time to sort of understand, but this thing here, 3x, is multiplied by x plus 2, and 1 is also multiplied by x plus 2. Okay, it's exactly like saying this. Going to do a bit of side math, but what we can say is if you've got 7 is multiplied by 5, plus 2 is multiplied by 5, okay, we can say that therefore that's equal to 7 plus 2, okay, they're both multiplied by 5, okay, because you can see up here that 7 is multiplied by 5, plus 2 is multiplied by 5. I've just written it a different way. So what we're going to do is we're going to come down here and probably do something that you may not have seen before, and that's completely okay. Is I'm going to get my 3x, so I open my brackets, 3x plus 1, and they are both multiplied by x plus 2. All I've done here is just rearrange how this thing is written to then be able to get to this thing down here. Now, it might take a little bit of time to get used to, but it's something mathematically we can do. And the reason is, like I said, this term here, 3x is multiplied by this whole bracket. And this thing here is also multiplied by the whole bracket. And if I expand them back out, you'll see, if I expand this thing here, you'll see that I get the original thing that we started with, which is kind of cool. Now, we're nearly finished. What we need to do is now solve them, because that's ultimately what we're trying to do. So we're going to let this thing here equal 0. And then null factor law, which we learned about previously. Null factor law says that either this thing here has to equal 0 or this thing here has to equal 0. Okay, and to do that, you put a number in for x to make that bracket be 0. Okay, so this one here on the right hand side, x plus 2 is going to be pretty easy. I'm just going to put x is equal to negative 2 in there, and that therefore makes that bracket 0. So x is either equal to negative 2 or we start to deal with this thing here. Now, as time goes by, you'll be quicker at trying to do it, but I'll quickly show you. We're going to go 3x plus 1. I'm just going to bring it down here and put it here. 3x plus 1 has to equal 0. So therefore 3x has to equal negative 1. And then we find out what x is, negative 1 over 3. So I've got my two answers there. I've got this thing here, x is equal to negative a third, or x is equal to negative 2, which is pretty exciting. We've got to the end of that. So, quick little recap of where we've kind of been, because there's lots of steps. And I probably should have put another step in here, because this one in here, I'll just quickly add it in now. This thing in here is we're going to solve. Okay, we're going to solve. Solve, that's step 4. Okay, so step 4 is to solve. Solve, and that's what we've done previously as well. So, quick little recap. We've gone through, we've had a little bit of a look at the steps, changed obviously from a monic to a non-monic, and we've gone through, found the factors that add to give me b. I've then split the b term up. and then gone through and factorised from there. Factorise in parts, which is this step in here. Factorise in parts, and then gone through and solved it. Stay tuned. I'll have some examples for you later.